In this lesson, we're going to simplify fractions involving radicals and learn to rationalize the denominator. When we simplify, we want to make sure that we're only simplifying fractions with numbers that are on the outside together or on the inside of a radical symbol. You cannot simplify numbers, one that's outside of a radical and one that's in. So let's look at example 6a. When we look at example 6a, we see that the 10 and the 5 are both inside of radicals, and so we are just going to be able to divide them. So we can rewrite them into a single radical if we like, but it's not required. 10 divided by 5 is 2, and so this is going to give us radical 2 as a result. Then we're going to look at that and ask, is there anything that we could do to simplify this further? Are there any perfect square factors of 2? And the answer is no, and so this is in simplest radical form. On example B, we have a 2 on the outside of the numerator and an understood 1 outside on the denominator. So we'll divide 2 by 1, which is just 2, and that'll be in the numerator of our next expression. Then we have a 15 and a 3, both on the inside of a radical, so we are allowed to simplify that. We'll divide 15 by 3 to get radical 5. 5 does not have any perfect square factors, and so this expression cannot be simplified any further, and so this is in simplest radical form. For example C, we have a 5 on both the numerator and the denominator, but we can't divide them because one is outside of a radical and the other is inside. So we're going to have to use a strategy called rationalizing the denominator to eliminate the radical from the bottom. We want to create a perfect square number on the bottom of the fraction so that we can take the square root of it and get rid of the radical symbol. The easiest way is to multiply by the same number that you see in the radical. That will create a pair of 5s, which is a perfect square. So if I multiply the bottom by radical 5, that'll give me radical 25 on the denominator, and we know the square root of 25 is 5. If I do that to the bottom, I also have to multiply the same thing to the top of the fraction. So I'll also have to multiply radical 5 on top. Let's go ahead and write down what we have on the bottom. So radical 5 times radical 5 is radical 25, and I know the square root of 25 is 5, so I've rationalized the denominator. On the top, I have 5 times radical 5, which is just 5 radical 5. Now, I have a 5 on the top and a 5 on the bottom that are both outside radicals. So 5 over 5 simplifies to 1, giving me 1 radical 5, and a simpler way to write that would just be radical 5. On example D, we have a 3 and a 6, both inside a radical, so we can simplify the fraction 3 over 6 to get 1/2. So now we'll have radical 1 over radical 2, or radical 1/2 if you wrote them together in the same radical symbol, but we can take the square root of 1, which is 1, so now we have 1 over radical 2, and we need to rationalize the denominator here. Well, again, we want to create a perfect square. We don't have to multiply by the same number, but usually that's the quickest way to find the number that will give us a perfect square. So we're going to multiply by radical 2 on the top and the bottom, giving us radical 2 on the numerator and radical 4 on the bottom. We'll take the square root of 4, which is 2, and put it on the bottom, and then we have radical 2 on the top. Now the bottom 2 and the top 2 cannot simplify to give us 1, because one of them is inside the radical and the other is outside. Neither can divide by a perfect square, and so this is in simplest radical form. On example E, we have a 6 and a 2 on the outside of the radical, so we'll simplify 6 over 2 to give us 3 in the numerator of our next expression. And then we have a 2 and a 5 inside of the radicals, but 2 over 5 doesn't simplify, so that'll just leave us with a radical 2 on the top and a radical 5 on the bottom. We'll need to rationalize the denominator by creating a perfect square on the bottom. We'll use radical 5 to create a pair of 5s, or 25 on the bottom, because 25 is a perfect square. We'll also multiply by radical 5 on the top. This will give us 3 radical 10 on the numerator of the fraction and radical 25 on the bottom. Now we're ready to simplify. We'll have a 5 on the denominator of our fraction because the square root of 25 is 5, and we'll have 3 radical 10 on the top. It's very tempting to want to simplify the 10 over 5, but the 3 and the 5 are on the outside of a radical, and the 10 is on the inside. So the 10 and the 5 cannot simplify together, and this is in simplest radical form. For example F, we have a -9 outside the radical and a 3 on the inside. These cannot divide together. It's tempting to want to divide them, but we can't. So we want to multiply by radical 3 on the bottom to create a perfect square of 9, and we'll have to do the same thing on the top. This gives us -9 radical 3 on the top and square root of 9 on the bottom. Now we're ready to simplify by taking the square root of 9 on the bottom of the fraction to give us 3. We'll bring over the -9 radical 3, and now we see that we have a -9 on the outside of the numerator, and we have a 3 that's not in a radical on the bottom. So we can divide these two. -9 divided by 3 is -3, and so this will give us -3 radical 3 in simplest radical form. I threw in an extra example here because I wanted you to see a situation where you didn't necessarily have to multiply by the same number to create your perfect square. Of course, if you multiply a number times itself, you will create a perfect square, but sometimes we can work with a smaller result if we choose. So our denominator here is radical 8, and we want to use that 8 to create a perfect square denominator. Our choices are from any number on the list of perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth. So when I'm looking at those numbers, of course I could do 8 times 8, which is 64, but 8 times another number would give me a smaller perfect square, like 16. So I could choose to multiply 8 times 2 and create a perfect square of 16 on the denominator, and then it will take less simplifying later in the problem. So I'm going to multiply this on the numerator and the denominator by radical 2, so that my denominator will become square root of 16, and I can take the square root, which is 4. Now I have 3 radical 2 over 4. Don't be tempted to simplify the 2 over 4. The 2 is inside a radical and the 4 is outside a radical. And we can't simplify 3 over 4, so this expression is in simplest radical form. Now you're ready to practice simplifying radical fractions and rationalizing the denominator. Good luck!